I'm Dr. Sitan, and this is one of the series of lectures on pediatric fractures. We will emphasize on the fundamental concepts of anatomy to ensure the better understanding of pediatric fractures, how to evaluate these fractures, and how the treatment depends on the knowledge of anatomy and understanding the basic concepts. This is famous saying, the children are not miniature adults. The bones are not small as compared to the adult, but there is a lot more difference in the physiology and anatomy of pediatric bone. When you look on the features of children bones, they have thick joint cartilage, they have thick periosteum, they have more collagen inside the bone, they have more cancellous portion of the bone, and there is a growth plate, and the ligaments are stronger than the growth plate. Each of these features they make the pediatric bone entirely different from adult bones. The pediatric bone contains higher water content and a lower mineral content that results in a low module of elasticity, and these bones they fail in tension and compression as well, but the metaphyseal area they fail in compression, while the diaphyseal area that fails in tension. Being more cancellous bone and more cartilaginous regions, the force is not propagated in the rest of the bone, and it is not communicated, and the fracture is not comminuted. And also there is a growth plate which is important for the growth of the bones in length, and there is periosteum which is richly supplied by the blood, increases the thickness of pediatric bone, and it also serves as a thick covering, and it resistant to the displacement of fracture fragments. So mainly the growth is because of the periosteum is thick, richly blood supplied, the ligaments are more stronger than the physes, so there is a lot more injuries of the physes as compared to the ligaments, and the metaphyseal vessels, they are ending in capillaries at the physis area, and this is a crucial region. The unique physeal anatomy of physis is basically a growth plate. It has got unique anatomy, histology. The epiphyseal vessels, they are entering to the epiphyseal area as secondary ossification centers, then these are ending up with the supplying the resting zone, and there is a proliferative zone, then there is a different columnar zone, there is a hypertrophic zone. This hypertrophic zone is basically not a maturation zone, and there is a death of the cells, and that ends up when there is death of the cell, there is a calcification over there, and this area is a region of calcification. And this vascular invasion is from the metaphyseal arteries. If there is injury towards the resting area, there will be arrest of growth on that side. And if there is injury or trauma to the metaphyseal side of the growth plate or physis, then there is a loss of osteoclastic activity, and there is overgrowth or asymmetrical growth of the physis, and they end up with the deformities at the fracture area. Knowing this much of anatomy is important to proceed for the further session in which we will look for these important layers of physis and their role in normal growth as well as the growth especially after the fracture. So summarizing this lecture, the blood supply to the physis is very important and it has two sides. On the epiphyseal side is more important than the metaphyseal side, as the epiphyseal side, if there is a disruption of the blood supply because of the injury, it will result in growth arrest. So consequences of growth arrest that occurs mostly on the epiphyseal side of growing bones. On the metaphyseal side there is osteoclastic activity which is going on. If there is disruption of the blood supply, this osteoclastic activity is lost and there is more cartilage and the cell death is there and there is ossification, more calcification, and there is asymmetrical growth. So you should be aware of the injury to the epiphysis or epiphyseal side.